B derives X SYX or BB or XAX SX or A, and X derives a new production is added. So here we add another production rule, Y is equal to Y derives B. Instead of BB we also place YY. Instead of BB we place, where B is present, we small b is present, we replace it to the Y. So in the here S0 AS, S0 AB, SB, S derives AS, S derives SB, A derives SX, and B derives YY, B derives XS are in the Chomsky normal form, and these also B derives A derives A are in the Chomsky normal form. So here S0 ASB is not in the Chomsky normal form, this is also not in the Chomsky normal form, this also not in the, this also, this also. So we replace that. So instead of XA we place another variable. So we take another variable P derives AS, P derives AS. So the production rule is like that. If you write P derives AX, P derives XA, so here you write P, here also you write P. So the production rule like that. Instead of P, here XP and XX. So the production is S0 derives AS, PB, SB, all are in the Chomsky normal form, and S derives AS, PB, SB, this is also in the Chomsky normal form. A derives SP and XS, A, this is also in the Chomsky normal form. B derives YY, XP, XS and P, these are in the Chomsky under Chomsky normal form. Only XYS is not in the Chomsky normal form. So we take another non-terminal or on another production rule to define that. So B derives SYS has more than two symbols. So removing it from this grammar L. So we take T as S, T derives SY. So instead of XYS we write T. So the final production rule is S0 derives AS, S0 derives PB, S0 derives SB, and S derives, this is, and next is S derives AS, S derives PB and S derives SB. Next production is S derives XP and or S derives XS, S derives A. These are the under the Chomsky normal form. Here if you add T derives XY, then it is T, B derives TS, B derives YY, TS or YY or XP or XS or A, this is also in the Chomsky normal form. So that is the all are in the Chomsky normal form. Finally we convert CFG to CNF by using removing the useless symbol, null production and unity production. Next we the final production is written here. Next rule for converting the CSV to CNF. So but why we convert the CSV to CNF, what is the need? So a lot of things we are doing. So what is the need of converting? Converting a CFG to CNF can be useful step in analyzing or processing natural language, as it allows for more efficient parsing algorithm to be used. So basically some of the parsing algorithm that use CNF, like CYK algorithm also use CNF, for that we convert, and it is a normal form. Next we go to GNF. So GNF stands for Greibach normal form. A grammar G said to be a Greibach normal form, GNF, is a standard form of the context-free grammar. In GNF, all production rules of the grammar are A derives A alpha, where alpha is non-terminals symbols, and the A is the terminal symbol, alpha is string of non-terminal symbols. In other words, the left hand side of every production rule is a single terminal symbol, and the right hand side of the belongs to the non-terminal symbols. So the rule says A derives small a, capital B. The non-terminal symbols are capital B1, B2. You can take any number of non-terminal symbols. So for example, G1 derives S derives A capital A B, or A B, A derives A, and you check this, these are in the CNF, because a non-terminal derives a terminal with two non-terminal. Here also a non-terminal derives a terminal with a non-terminal. A non-terminal derives here is also in the Greibach normal form, but if you check second G2, it is not in the CNF, because there is a epsilon production is present. So for that B derives epsilon, for that it is not CNF. So the rule for steps for converting the grammar into CNF. First we convert the grammar CNF, then CNF after converting the CNF, we remove the left recursion, then we convert in the CNF form. Third is the convert to the CNF form. I will give an example here. And so left recursion. So before doing the left recursion, all are you known, then only left recursion is remaining. So grammar stands for G is equal to VTPS, and the left recursion is, it has the production in the form A derives A alpha or beta. If you like that, then this is a left recursion, A derives A, this is known as left recursion. If the production is like that, simply you replace A derives beta A dash, you add a new non-terminal symbol A dash, and A derives alpha A dash or epsilon. Simply write that. So simply you create a non-terminal symbol and derives, and add that non-terminal symbol at the end and add a epsilon. So this is the example. First we check this example is in CNF or not. If CNF, then you convert to CNF, then you remove the left recursion. Here S derives XB, XA. This is the form of, because a non-terminal derives two non-terminal, so it is in the CNF. A derives A, it is also in the CNF, and A derives XA, a non-terminal derives also two non-terminal, it is also in CNF. Capital derives B, it is also in the CNF, because a non-terminal derives a terminal. X derives A non-terminal derives a terminal, it is also in CNF. So here this production rule is in the CNF form, and here also you check there is no left recursion. So we can skip step 1 and step 2, then directly go to the step 3 for CNF. So first A derives SA is not in CNF. So we substitute X derives SB. So we substitute here SA, instead of S we substitute this. It means we write A derives X, instead of X we write A derives A, XBA or AAA. Okay. Then the production rule is like that. Simply we substitute S derives XB, XA in this S. So XB, S derives SB, we add here B derives B and X derives A. So here we add here X derives A. So here X derives A means it is a B A, and here is also A, and these